We identify different types of sequences, and we're going to write the equations to these type of sequences. And the two sequences we're going to look at are arithmetic and geometric sequences. Alright, let's look at a couple examples here. A, B, and C, if you want to copy these down in your notes, might be a good idea. For each one of these I'm going to use the x values of 1, 2, 3, and 4, and then I have different y values. Now notice for the first one here, for the y values, I start at 3 and go to 7, 7 to 11, 11 to 15, and notice each time I'm adding 4. Whenever you're adding the same number each time, it is considered an arithmetic sequence. For the second one here, it looks like 48 to 24, I'm multiplying it by 1/2. 24 to 12, I'm multiplying by 1/2, and 12 to 6, I'm multiplying by 1/2. In this case, I'm multiplying by the same number each time. That is geometric. So that's the difference between the two types of sequences. Arithmetic, you add the same number, it's called the common difference. Geometric, you multiply by the same number, and that's called the common multiplier. Now if we look at this letter C here, you'll see that we are not adding the same number each time. We're also not multiplying by the same number each time, so we consider that neither sequence. In fact, if you look at it, there's actually going to be an x squared in that, and we'll talk about that a little bit later in this video. Alright, let's look at some more examples. Pause the video right now and see if you can figure out if that is arithmetic or geometric. Alright, so we consider this 1.5 the first term, 3 is the second term, 6 is the third term. So in this case, this is going to be geometric because 1.5 times 2 is 3, 3 times 2 is 6, and 6 times 2 is 12. It is multiplied by the same number each time. Now if we want to write the equation to this, we need to come up with the initial value. Now the initial value is when x equals 0. So I'm just going to make a little table here and fill in the numbers that we have. And notice I need to find the initial value. What does y equal when x equals 0? So if I multiply by 2 every time, if I go backwards, I mean I'd have to actually divide by 2. So I think that's going to be 0.75. So when we write the equation, we're going to start with the initial value times the common multiplier, and then we have that to the x power, the independent variable. That is for geometric sequences, so that you're going to want to copy down your notes. That's going to be the same for every geometric sequence. It's always the initial value times the multiplier to the independent variable exponent. Alright, let's look at the other one, and you can guess that I'm going to make this one arithmetic, so I'm adding a -4 each time. So this is arithmetic. So again, to write the equation I need the initial value, so I'm putting down the information that we have. So again, if I'm adding a -4 each time, if I go backwards I'd have to add 4, so therefore 16 plus 4 is 20, and therefore I can write my equation. Now arithmetic sequences are a little different. You start with the slope, which happens to be the common difference, so -4 times x, the independent variable, plus 20. Now that kind of makes sense to you because the slope is how much it changes by every time. You learned that in Algebra 1. And the initial value is the y-intercept, where x equals 0. So that in reality, there's some new terms that we use, but you already know all about that one. Let's look at some more examples. Pause the video right now and see if you can figure out which this one is, arithmetic, geometric, and see if you can write the equation. Alright, so let's see what we have here. The common difference. Hopefully you figured out that the common difference here is -1. The initial value, hopefully figured out, is 5. So therefore the f of x is equal to -1x plus 5. Pause the video right now and see if you can figure out this one. Alright, this one is very similar to the one that we did earlier. Our common multiplier again is 1/2. The initial value, if we go backwards, is 36. So therefore remember the general equation. G of x is equal to the initial value 36 times 0.5 to the x power. Alright, let's try one more. Alright, so if you pause the video, you're going to figure out that there is no common difference or common multiplier, so therefore, that's a neat representation of the word therefore, it is neither. However, let's look at something cool about this sequence. if I find the common difference here, notice that it goes up by 6, goes up by 10, goes up by 14. Now I'm going to do that again. This is called the second difference. So I'm going to find the difference of the differences. Now between 6 and 10 there's plus 4, and between 10 and 14 there's plus 4. Notice how the second difference is the same. Well, whenever the second difference is the same, that is a quadratic sequence, x squared. Now, our textbook does not study quadratic sequences. However, I think we should be aware of these type because they could be on an SAT, ACT, possibly an MCA test, but I haven't really seen them on an MCA test before. But it's possible that it's there. So h of x is equal to 2x squared plus 1. How did I find that? Basically guessing and checking. I knew there was going to be an x squared in there, so I just had to look at the pattern and figure it out. Now there is ways to do that. If you want to figure that out, you can Google it, how to find quadratic sequences, equations. I'm not going to get into that because our textbook, like I said, does not cover those type of sequences.